Okay, so that video clip you just saw was actually done by some students and uploaded. It's a little bit of a taste of one of the things we're going to talk about today in our video lecture about an electron cloud. We're going to get there in a few minutes, but I want to make sure that you have your Chapter 4, Lesson 2 notes. They look just like this. We have a few definitions to get through, not too much, and then a few things to talk about in regards to getting a little more in depth on what we did in Chapter 4, Lesson 1 notes, which was pretty much just basic structure, and now we're going to get a little bit deeper into that stuff. So, have your notes in front of you. I'm going to go to my PowerPoint right here. Let's start it at the top. So lesson 2 is titled Discovering Parts of the Atom. So you kind of got into particles and knowing what they are, what their charges are. Now we're going to go a little bit more in depth. So the first definition that you have is a spectral line. And this can seem extremely confusing to people. So I have, what in the world is a spectral line? Basically, it's a single wavelength of light that can be seen when the light from an excited element is passed through a prism. And that probably makes absolutely no sense to you. But basically, a spectral line is a color given off by an element depending on how much energy or excitement it gives off. So each element has a different amount of energy or excitement, and that energy gives them specific colors. So for example, at the bottom here, you've got 3 different examples of spectral lines. You have one for hydrogen, one for neon, and that bottom one, it looks like the screen isn't picking up what the element is, but it's iron. So they go kind of from more simplistic at hydrogen down to the bottom with iron that has lots and lots of lines. Basically, what the lines are telling you, if you take a look at hydrogen, is where there are bands of color, it means that that's the energy being given off by that element, and that's what the colors mean. At those specific wavelengths where those colors are, it has energy it's giving off. So in your notes, you're going to now, it says draw an example of the spectral line for hydrogen. So go ahead and just give me a representation of that. And if you can do it in color, that would be great. The 3 or 4, I think there's 3 spectral lines, 4 spectral lines. If you can give me those in colors similar to what we have, that would be great. And it says, what do the colors show? And I just told you what the colors showed, so you're going to write that. Okay. The next one is energy level. So energy level is a region of space in which electrons can move around the nucleus of an atom. So remember, in the nucleus we have the protons, which you can see there by a plus sign, and then we have neutrons also, which aren't represented here. But it's basically just telling you that the nucleus is overall positive, which we talked about in a class yesterday, 2 days ago. And its energy levels represent where electrons can move. And again, we talked about this a little bit, but electrons are not static. They do not stay in one place. They move, and they are fast, and they are random, and they just go all over the place. So an energy level is like a temporary home for an atom. It's going to be there for a little bit, and then it's taken off and it's going somewhere else. So energy level is a space where electrons can move around the nucleus. Okay, so we have the electron cloud video, and you got a little bit of quick information there about that, but basically what you need to know is pretty simple. The electron cloud is a region surrounding a nucleus where an electron is most likely to be found. So the electron cloud is a place where you're most likely going to find electrons. That's pretty simple. We've gone from lots of models that you guys saw for like Democritus, Lavoisier, and all those scientists in lesson 1. They had these very specific ideas about what the atomic structure looked like, and now we know through a ton of research and everything as we get more technologically advanced that the electron cloud model is more likely to be more correct. So there's a space around a nucleus where we can most likely find electrons. Okay, so your last definition is Bohr diagrams. And a Bohr diagram shows the energy levels, the number of protons, neutrons, electrons in an atom of an element. And this is in 2 dimensions. So when we draw this kind of energy level for atoms with these, little circle shells, and then we put the electrons on, that's really only to give us a picture of what it would look like since we can only draw in 2 dimensions on a flat piece of paper. That's not exactly what an atom looks like. The electrons don't travel on these perfect circles in perfect harmony with each other. They have that electron cloud model where they could be anywhere in there. But because of the limitations of what we can do with drawing a diagram, we have to draw it in 2 dimensions. So that's what a Bohr diagram does for us. It shows it in 2 dimensions. So the energy levels or shells of atoms can hold different amounts of electrons. So down here in your notes, I want you to give me how many the first electron shell can hold, and I have it here, second, third, and fourth. So the first level of shell can hold 2, the second shell or level energy level can hold 8 electrons, the third level or shell can hold 18, and the fourth can hold 32. Basically, I'm going to give you an example that most people find easy to remember. So each energy level of an atom can only hold a certain amount of electrons. Okay, so I'm giving you the car/seatbelt examples. So the first shell is like a Ferrari. It only has 2 seatbelts. Ferrari only has 2 seatbelts. So it can legally only hold how many people? 2 people. 2 seatbelts, 2 people, or 2 electrons. The second shell is like the mommy minivan, and that has 8 seatbelts, and it can legally hold 8 people or 8 electrons. The third shell is like a stretch limo. It has 18 seatbelts, so it can legally hold how many? 18. And the fourth shell is like a school bus. It has 32 seatbelts, so it can legally hold 32 people, or for our example, 32 electrons. So if you get confused about the energy levels of an atom and how many each energy level or shell can hold, it might be helpful to come back to this example to remember that 2, 8, 18, 32. That might be helpful to think of it as cars and seatbelts and how many each one can hold. Okay, so that's the end of the notes portion of today, and I have a video for you, and I promise this time this one's going to work. Okay, this is Steve Spangler, ping pong balls. He's got 40,000 ping pong balls and some liquid nitrogen. So let's see what happens.